Okay, today we're going over 9.6, solving rational equations. So let's start off by looking at a rational equation that's going to have a fraction equal to a fraction. Okay, so if this is the case, what we're going to do is we're going to cross multiply here. So we'll multiply 5 times x squared minus 1, and we'll set that equal to 15 times 2x minus 2. So distributing our 5 in and distributing our 15 in, we get a 5x squared minus 5 is equal to 30x minus 30. So since we have an x squared on one of the sides, we're going to bring everything to one side. So I'll subtract 30x, I'll add 30 to both sides. So I'll get a 5x squared. Subtracting 30x, I'll get a minus 30x. And then I'll add 30 to both sides. 30 minus 5 is a 25. Setting that equal to 0. I can see that 5 can go into everything. So since it's an equation, because it's equal to 0, I can divide everything by a 5 and simply get an x squared minus 6x plus 5 is equal to 0. So from here, I can factor it by saying what multiplies to 5 and adds up to negative 6. And that's going to be an x minus 5 and an x minus 1. Negative 5 times negative 1 is 5. Negative 5 plus negative 1 is negative 6. From here, I'll make my t-chart and get x equals 5 and x equals 1, which these are the solutions that we came up with, but now we still need to check for extraneous solutions here. So we're going to do that by plugging it into the original problem. So if I check x equals 1, I'm going to plug x is negative 1 here into my original. So 5 over 2 times 1 minus 2. And we want to know, is that equal to 15 over 1 squared minus 1? So if you look here, we can already see this is a 5 over 2 minus 2, which is a 0. And you cannot have 0 in the denominator. So x equals 1 is an extraneous solution. So this is not going to be a solution of our equation. Now we could check x equals 5, and when you check that by plugging in x equals 5, this one will work out. So x equals 5 is our only solution for this problem. Okay, moving on, we are going to look at when we have more than 2 fractions here. So here we have a fraction minus another fraction equals a fraction. So normally we're used to combining and getting a common denominator here. So what we're going to do now is we're going to make it a lot easier, and we're going to multiply both sides by the LCD, or the least common denominator. So the LCD here is going to be, well, the least common multiple of 2 and 5 is a 10. And since we have an x in here, it's going to be a 10x. So I'm going to go ahead and multiply everything by my least common denominator. And what that's going to do is it's going to cancel out all of your denominators. Okay, so we have a 10x over 2x minus, I have 2 times 10x over 5x is equal to 10x over 2. So I didn't multiply it in because now I'm going to be able to see, okay, what can I cancel out now? So my x's will cancel. 10 over 2 is a 5. The x's will cancel here. 10 over 5 is a 2. And 10 over 2 here is a 5. So now writing what we have left, we'll see that there are no more denominators. They all canceled out. And now I'm left with a 5 minus 2 times 2 is a 4, which is equal to 5x. 5 minus 1 is a 1, which is equal to 5x. I'll divide both sides by a 5 here. This will cancel, and I get x is equal to 1/5. And then I'll have to plug it back in to check for extraneous solutions. When I plug 1/5 back in, it does check out correctly. Let's try one more of those. So here, our at least common denominator, since one is a binomial and one is a monomial, we will just multiply them, x times x plus 1, and that will be our least common denominator. So I'm going to take this and multiply everything here by x times x plus 1. And remember, I'm not going to multiply this out yet because things are going to cancel out. So I have a 4x times x plus 1 over x plus 1 minus 3x times x plus 1 over x plus 1 is equal to x times x plus 1. Okay, now we can cancel out what we can. Oh, sorry, here, this should be, sorry about this one here. This should just be an x over here for the denominator. There we go. Okay, and then everything else is good. Alright, so we're going to just cancel out what we can here. Canceling out the x's. Canceling out the x plus 1s. Nothing cancels there. Okay, so now we're going to just write what's left, and all of our denominators should be canceled by then. So we have a 4x plus 1 minus a 3x is equal to x times x plus 1. And here I will distribute it in my 4x plus 4 minus a 3x, bring that down. Distribute in my x here, x squared plus x. Combining like terms, I have a 4 plus x equals x squared plus an x. Subtracting an x from both sides, I'm left with an x squared is equal to 4. Now I could just take the square root of both sides, and remember, when you take the square root, it's always a plus and a minus. Plus and minus 2 there. You guys can go ahead and plug these back in to check for extraneous solutions, and they both check out. Okay, this one is solving for the given variable. So if we actually go ahead here and we get one of the fractions to the other side, we're solving for e here. So I'm going to just add 1 over mc to both sides and get c over e is equal to 1 over mc. We said that when we have a fraction equal to a fraction, I'm going to cross multiply here, and I get e is equal to c times c is c squared. That's it. Alright, working on some word problems here. We can go ahead and fill out this chart. So it's saying Carlos can travel 40 miles on his motorbike. In the same time, it takes Paul to travel 15 miles on his bicycle. Okay, so we should remember the equation of distance equals rate multiplied by time. And then we can see if Paul rides his bike 20 miles per hour slower than Carlos rides his motorbike, find the speed for each bike. Okay, so let's say that Carlos rides at a rate of r. That means that Paul will ride at a rate of, Paul rides his bike 20 miles per hour slower. So that means whatever Carlos is riding, whatever Carlos's rate is, r, minus 20 miles per hour. They're going the same amount of time, so that means that they both will have a time of t. And if I just take this equation here, d equals rt, and I solve for t here, I can divide both sides by r and get time is equal to the distance over your rate. So using this, I can say that Carlos's time is his distance over rate, or 40 over r. 40 over r. And Paul's is distance over rate, 15 over r minus 20. So setting these equal to each other, since they're going the same amount of time, I'll have a 40 over r is equal to 15 over r minus 20. And then I can cross multiply here, getting 40r minus 40 times 20 is 800 is equal to 15r. Okay, we can subtract 15r over and add 800 over. 40 minus 15, that will give me a 25. Oops. That will give me a 25r is equal to 800. Dividing both sides by a 25, I get r is equal to, 25 goes into 100 4 times, so 4 times 8 is a 32. So we got r to be 32, and then we can come back up here and see that we have Carlos's rate. So Carlos's rate is 32 miles per hour, and Paul's rate is going to be 32 minus 20, which is going to give us 12 miles per hour. And that will be the rate for each of the bicycle and the motorbike. And that's all for today.